Hello everybody. Today we're going to do types of chemical reactions. So you already know how to do balancing equations. Now once you balance an equation, you're going to also tell me what type of reaction you have. And there's 5 different reactions, okay? So using the law of conservation of mass, which you already learned, whatever you had on the reactant side, you must have on the product side. So you must balance the equation first and then give the type of reaction. Okay? Now, so today you're going to not only be able to balance the equation, also, or figure out the law of conservation of mass, you're going to also identify what type of reaction the example is. Okay? Okay. So let's go over the 5 different types. Here you have, now they're using A plus B equals AB, but let's use an actual equation. So let's make something up, like sodium and chlorine. They come together and they create salt. This is a synthesis reaction or a combination. Okay, now what happens here is I always think of it as, or I always give the example as relationship terms. So boy, let's say sodium's your boy, meets girl, they go to a dance, they meet each other and they become a couple. Okay, so it doesn't matter whether you have 1 element, 2 elements, 3 elements, or an element in a compound, as long as it makes one big compound. That's it. That's a synthesis reaction. Okay? All right, so now let's do decomposition. And let's use a different version. So let's say you have KBr, potassium bromide. Potassium bromide are a couple. They go to a dance, they get upset with each other, and they break up. So you have potassium by itself, and bromine is a diatomic molecule, so it has the little 2 on the bottom. That is decomposition, so breaking up, or it separates, or divorce, okay? So it can separate into 2 different elements, or it could separate into a compound and a different element, as long as you had 1 compound to start with, and it breaks apart. It doesn't matter if it breaks apart into 2 or 3 different elements or compounds. It is a decomposition reaction. Okay? Now, if you have a question, stop the video and go ahead and ask me through Zoom. Okay, so now, single replacement. You have a couple that goes to a dance. Let's go back to sodium chloride and bromine goes by itself. Okay, a couple go to a dance, a single guy goes to a dance, girl gets upset with boy, breaks up with boy, and goes with the other boy. Okay, so now sodium is going to be with bromine, and now chlorine is all lonely by itself. Okay, that is a single replacement reaction. And so notice you always have an element on its own. Okay? All right, so now double replacement. Double replacement, 2 couples go to a dance. And let's go back to potassium bromide. Okay, now what's important to remember here is that you always have a cation and an anion, a plus and a minus. Okay, this plus will go with this minus, and this plus will go with this minus. So 2 couples go to a dance, they get upset with each other, they break up and switch partners. So now sodium is going to be with bromine, and potassium, let's move this over here, is going to be with chlorine. You see how they switched partners? That is a double replacement. Okay, very good. Okay, and I just noticed that combustion is missing from here. So we're going to do that in a little bit. Okay, now here's your fifth type of reaction. You have combustion. Now this is something that's going to explode. It's going to give off heat, okay? So now you can have any carbon or hydrogen, but this is the important part, the most important part. It's going to always react with oxygen. It's going to always produce carbon dioxide and water. So this back part of the equation always stays the same. This is a combustion reaction. Okay, so you can have something like, let's say C2H6. You're still going to have the oxygen gas, the carbon dioxide, and your water. Your product will always be carbon dioxide and water. This is a combustion reaction. Okay, so this is one of the easiest types of reactions to figure out because this will always stay the same. Okay, and you can even include, let's say you include a hydroxide group or a chlorine group or something like that. It's still a combustion reaction because of all of this, okay? Okay, so let's go over this one more time. If you have one element combining with another element and it makes one big compound, that is a synthesis reaction or combination reaction. Okay, most of the time you're going to find it as synthesis. Okay, if you have a compound all together and it separates into two separate elements or an element in compound, that is a decomposition reaction. They break up, they separate. Okay? A combustion is the one that we just did. Any carbon and hydrogen that reacts with oxygen gas, it's going to always produce carbon dioxide and water. This is a combustion reaction. Okay, now let's look at this. This is a neutralization reaction. That means you have an acid. How do I know this is an acid? Anytime you have an H in front, that is an acid. How do I know this is a base? Anytime you have an OH at the end, that is a base. So anytime you have an acid plus a base, it's going to always produce water and salt. Let me say that one more time. This will always happen, and it is a double replacement reaction. Anytime you have an acid and a base, it will always give you a water and a salt, any type of salt. Okay, and it's a double replacement reaction, always. It neutralizes. Okay, so now let's look at this bottom one. Here I have a compound, silver nitrate, and I have another compound, sodium chloride. This positive is going to go with this negative. And this positive is going to go with this negative. So sodium's a positive, nitrate is a negative, silver's a positive, chlorine is a negative. So now you have silver and chlorine and sodium and nitrate. You see how they switched partners? This is a double replacement reaction. Okay? Okay, so now let's do a couple of examples together and see what type of reaction it is. So you're going to tell me whether it's synthesis, decomposition, single replacement, or double replacement. Now, if you want to, you can stop the video and try to do this on your own and then turn it back on and double check yourself. Okay, so if you want to double check yourself, go ahead and pause now and give it a try. Okay, here we go. You have zinc alone and you have sulfuric acid. The hydrogen breaks up with sulfate, so zinc goes with sulfate. So now hydrogen is all alone. This is a single replacement reaction. Okay? All right, so now let's create some space for the second one. Okay, sodium is by itself, bromine is by itself. It creates one big compound, So that means they all come together and make one compound. That is a synthesis reaction. Okay, here you have hydrogen and chlorine, that's a compound. You have sodium hydroxide, that's a compound. Sodium goes with chlorine, and hydrogen goes with the OH, which is water. HOH becomes water. Since they switch elements or compounds, it is a double replacement reaction. Okay, let's do number 4. Here you have peroxide, and it's one big compound. And it separates into a compound and an element. You have water and oxygen gas. That is decomposition because you started off with one compound and then it separates out. Okay, number 5. You have copper by itself and silver nitrate is your compound. Silver dumps nitrate, goes by itself, and now copper is with nitrate. Okay, silver is all alone. This is a single replacement. Okay, let's make this the last one. Here you have carbon and hydrogen. Here you have oxygen gas. You also have carbon dioxide, and you also have water. This looks similar. What do you think it is? It's combustion. Okay, remember that one, the only thing that changes is the compound that's in front, and it's just the numbers. You must have a carbon and you must have a hydrogen. Okay, very good. If you want to do the next 3, we can do that during Zoom. Very good. Let me know if you have questions.